Hello everyone, this is Ikusahime from the AP Stats subreddit, and this is Section 3, Week 1, Analyzing Patterns in Scatterplots. Scatterplots are a way of visualizing relationships between two quantitative variables. Sometimes you'll see this mentioned as bivariate data. In the last few sections, we've only worked with univariate data, or one variable data. Bivariate means that there's two. If you recall from the first section, quantitative, just as a refresher, means that we can calculate measures from the data and it would still make sense, and our data is numerically represented. So just like other graphs, scatterplots have an x-axis and a y-axis. Let's start with the y-axis. On the y-axis, we have our response variable. The response variable is simply the result of the study, or whatever comes out of it. Sometimes you'll see this referred to as the dependent variable. On our x-axis, we have the explanatory variable. The x variable aims to predict or explain the y variable. Sometimes we call this the independent variable. Take this with a grain of salt though. Sometimes when we plot the explanatory variable against the response variable, there's no association at all. So the x variable doesn't actually explain the y variable, and that's also a possibility. So I think a better wording for this would be that it can be used to predict the y variable. So let's go over a few examples. So for example, let's look at the income of a country and the overall healthiness of its population. Which one do you think is the explanatory variable and which is the response variable? I would say that the income is the explanatory variable. And the health is a response variable. Because if you plot a scatter plot of the income on the x-axis and the health on the y-axis, you can see that as the income increases, the health of the country also tends to increase. Here's another example. Studying and GPA. I would argue that studying is explanatory and the GPA is the response. Because usually the more people study, the higher their GPA tends to be. This one's going to be a little different. My stats teacher used this example last year when I was in his class. So let's take hot dogs and lung cancer. This is a really important concept in AP Stats. You might have heard this in a different math class that you've taken, but correlation does not suggest causation. So let's say we plotted hot dogs on the x-axis and lung cancer on the y-axis, and it happened to be that it looks like the more people eat hot dogs, the higher their likelihood that they'll have lung cancer. But does this mean that eating more hot dogs causes you to have lung cancer? Well, sometimes these scatter plots can be misleading if you interpret them in the way that it wasn't intended to be. Just because we can predict the response from the explanatory, so if we knew that the x value was this, then we can infer that the y value would be this. Doesn't mean that the explanatory variable causes the change in the response. It just means that they're related somehow. Okay, we're done with definitions. So let's make a real scatter plot. So this isn't just data that I made up on the fly. If you want to see the raw data source, then you can see that URL down in the description. In this experiment, we were looking at if stretching a rubber band more tends to have an increased distance that it's traveled. So how much we stretch the rubber band would be our explanatory variable. And how far it travels is our response variable. So bear with me while I write down this data. Hope I don't run out of room. There should be 44. So these are still the explanatory variable values. I'm just continuing them over to the right here. And here are the response variable values. So in total, there should be 23 pairs of values. What I want you to do now is take out a graphing calculator. I'm going to do this on a TI-84. So once you have your graphing calculator, go to Stat, Edit, and select the first option. In L1, you'll put your stretch values, your explanatory variable, and in L2, you'll put in your distance, your response variable. I'll give you a minute to put those in, and a chance to pause the video. When you've finished putting the data into L1 and L2, then go to second y equals, and that should take you to the Scatterplots menu. So once there, select your first open plot. For me, it's plot 1. The first thing you want to do is check that your plot is turned on. If it's turned off, you won't be able to see it when we go to the graphing step. And for type, we want to select the scatterplot, which is the first one on the very left. Your X list should be L1, where we put our stretch values, and our Y list should be L2, which is where we put in our distance values. When you finish selecting your values in the stat plot menu, then go to Graph. And if this shows up weird for some reason, then you might have to go to Zoom 9, Zoom Stat, to make it appear correctly. When you have it all plotted out, it should look something like this. Just this upward trend of dots. So when you're analyzing a scatter plot, there's really 4 things that you're looking for. Number 1 is direction. Direction is, where is the trend going? In the case of our rubber band launching distance, it looks like the more you stretch it, the more the distance tends to be. This is what we call a positive association, because as x increases, y tends to increase. But what if the distance the rubber bands traveled decreased as we increased the strain? Then our plot would look something like this. So now as x increases, our y tends to decrease. And this is a negative association. The second we're concerned with is the form of the relationship. The form is basically what is its general shape. So if we had a scatter plot that looked like this, if we drew a line through it, it looks like it follows a pretty linear pattern with a negative slope. So we can call this one linear form. Or here's another example. What if our points looked like this instead? Then our points would be along a curve. And this one could be curve form. Something that's related to form is the strength. How well do the points we picked out correspond to the form? In the case of the linear one we have up here, most of the points are really close to our line. So we would say that this is a strong linear. In contrast, if you had something like this instead, then this would be weak. See how this is really scattered compared to this, where it conforms to a line, and how this one conforms to a curve. Finally, we have outliers. Outliers and scatterplots are kind of like how we discussed outliers in the first two sections. So if you have a scatter that follows this general upward trend and looks like it could fit a linear model, and you suddenly saw this point, it's like way over here and it's far away from the main group over here, then we call that an outlier. Because it influences how we mathematically interact with the other points. Alright, that's it for this week. If you have any questions, feel free to drop a message down in the comment section below or shoot me a message over on Reddit. And see you next week.